What?
It smelled like gas. Like we walked in, it smelled like gas.
Matthew?
It smelled like gas.
I know, but did you have your hand up too?
Yeah, that's what I was going to say too.
Does it smell like gas in here?
Yeah, passed out. You passed out, look. Nico passed out.
Nico, are you passed out? So what do I owe the incredible honor of having the Orange Grove bus on time? Okay, we're going to do a little review of Chapter 9, the first part of it, and then later on we're going to take new material, so... Pardon?
We can take a picture of the slides with our phones.
Yeah, sure. Is everybody done talking now? Okay, if you want to continue talking, go out and sit in the warehouse.
Are you going to mark me absent?
Eric? I thought you were done talking. Maybe you're never done talking, right, Eric? We talked about the end of commercial aviation, but we're going to cover that again in review form. Right now we're talking about the space race. So, since you've all read that chapter, any questions? Well, we know that there were three major bodies, three major organizations trying to get into space. Obviously, Russia, the United States, and Europe. The big deal wasn't putting it into space. The big deal was getting it back again. And so the Russians tried very hard. They actually set quite a number of firsts for space operation. Then along came NASA in early 1960, when the military was trying to take control of space operations. The president at that time said, no, we're going to let a government organization like NASA, we're going to let NASA handle all of the space flights. So that meant that there wouldn't be a waste of money between the competition among the four defense forces, especially the three, the Army, the Navy, and the Air Force. So NASA got started planning for the future, planning to put people into space and get them back again. Meanwhile, Russia was ahead, and they were already putting satellites and people into space. But as it points out there, most of these flights were non-commercial. They were just trying to get payloads into space and get them back again as a test. One of the things that we're happy about today is the fact that both communication and weather satellites helped pay the bill, because today we have probably the finest weather system in the world because of the sophistication of the satellites that we've put up there to determine weather. In fact, with one exception, the Europeans, we actually provide weather observations and weather computations for almost the entire world. Japan has one up there. The Europeans have one up there. We have numerous satellites up there that we depend on the weather from those satellites. Andrew. If I put the what, why does it? I doubt it. Just like the Russians have already planted a flag on the North Pole under the water. They're trying to claim it for themselves so that they can mine whatever minerals are up there in that area of the world. But the fact that we put a flag on the moon, that's a good question. We put a flag on the moon. I believe that this country doesn't expect that we're going to charge entry fees to land on the moon. I think that we recognize that everything beyond 328,000 feet, which is the beginning of outer space, everything beyond that level belongs to no one. And let's hope there are no wars in the future to try to determine who owns what when it comes to the moon or other places like Mars. You know, I need to ask you a question. Is it necessary for you to continue to talk during this class? Is there something about your vocal cords that keep vibrating and you can't control yourself? And by the way, whoever happens to listen to this recording is going to be able to understand that there might be a problem with chatter in this room. Because I'm not going to edit or modify this recording. It's going to go up on the internet just exactly the way we're talking right now. Pretty funny, huh, Jesus? One of the things that we did was the X-15 program, in which we were doing research into hyperspeed. At the same time, we were also doing research into upper space. But more importantly, the X-15 was there primarily for speed determination, that what happens at high speed, what happens at speeds beyond 3,000 miles an hour. Since we've already had balloons go up as high as 100,000 plus feet, we didn't really need to know an awful lot about the upper stratosphere. What we needed to know is what happens in the various realms of speed, and the X-15 at the time was by far the fastest vehicle in the world, fastest aircraft. Then along came the Mercury project, and each of these projects, as you see listed, continue to develop a little bit more about space each time. In the case of the Mercury project, Alan Shepard was the first in space for the United States, but he certainly was not first in space overall. The Russians had that a long time ago, way before Alan Shepard. They sent Yuri Gagarin into space. I'll cover that in a minute. But Yuri Gagarin was their first human in space. The Gemini project, a little bit more advanced. The Mercury project had only room enough for one person tightly crammed into a small little capsule. The Gemini came along and said, gee whiz, now we have two people in the capsule. They were still crammed in very tightly. But at the same time, they were able to have a hatch that could open up. And they did the first spacewalk. Then the Apollo project came along. And the goal of the Apollo project from the very beginning was to go to the moon. Unfortunately, one of the earliest attempts killed 3 astronauts, and they were on the ground in Indiana at a test center, and they were testing the various systems, and all 3 astronauts were inside the capsule when something happened and a fire broke out inside the capsule. And the biggest problem was they all couldn't get out in time, and they all died. So as a result, there was a presidential commission formed to try to understand why it was that NASA would design a capsule that would be very difficult for the astronauts to get out of. And it wasn't just a matter of a question of a fire on the ground. It's a question of what happens when it lands in the ocean. How are they going to be able to get out if that capsule, for whatever reason, starts to sink? Which, in fact, one did. It started to sink before all of them got out. And they got out successfully, but they got out pretty wet. So anyway, there were some modifications made to the capsules from the time of the 3 astronauts who died. And unfortunately, in the shuttle program, we had more people die, but in the Gemini and Apollo projects, we didn't have anybody die except those 3. NASA became a lot more careful about safety. And so as a result, we spent a lot of time on the safety issue, which put us behind the Russians, because the Russians did not necessarily care about safety as much as the United States did. They sort of felt like they were expendable. At the time, one of the men who was in charge of their space program had been imprisoned by Stalin. By the way, over his lifetime, people have estimated somewhere between 30 and 40 million people were killed by Stalin. Stalin was so brutal that if you looked at him wrong, he would send you to prison for years. He would kill people with almost no reason, or have them killed. So they were in a situation where they really didn't care so much about human life. What they wanted to do is they wanted to get ahead of the United States and show the world that they were a #1 country, which everybody in the world recognized they weren't. They were neither a #1 country in a lot of areas, but especially in human rights and freedom. So the Apollo project, we did get to the moon. We had a couple of real close calls. One in particular had to be brought back, Apollo 13 as I recall. If anybody's seen the movie Apollo 13, it was about the problem of going to the moon and having some significant onboard problems that finally were solved by the NASA engineers in the United States while the shuttle was up, while the capsule was up there roaming around. In any event, they were able to get them to come back safely, but not without a tremendous amount of urgency. They were real concerned about losing those 3 crew members. If you ever have an opportunity to see it, that movie, I don't remember how long ago it was made, but it was called Apollo 13. And it was really one of those movies that was almost so true to life that you could sit there with sweaty palms just watching it, because it was that you could not help but be that concerned about the safety of those people on board that aircraft, on board that Apollo. So then the Skylab came along, and this is one of those things where we were talking about something that goes up there and stays up there, and we visit it frequently back and forth. And but in the meantime, as an aside from that, the Russians had already put up Mir, M-I-R, which was their first attempt at a space lab, and it was successful, and it remained in orbit for more than 5 years. So the Skylab project was mainly for science and engineering. It wasn't necessarily to prepare anybody to go to the moon. It was to understand how long people can spend in space, what happens to their bones, what happens to their whole body when they're in 0 gravity. And as it turns out, they lose a lot of bone mass when they're up in space. And if they don't exercise, they lose a huge amount of their muscle power. Their muscles begin to atrophy. Everybody know what the word atrophy means? Atrophy, yeah. Your muscles begin to shrink because they're not used. So we learned a lot in aviation and in space because of the Skylab project, and then of course the shuttle project. We learned to build things in space. We learned to put up things like the phenomenal Hubble telescope, which brought back to the United States and to the world pictures we never would have seen otherwise of what the universe looks like. Oh, and by the way, let's go back this one for a moment. The shuttle project, we know about Columbia and we know about Challenger. And unfortunately, in situations like that, nothing worthwhile that requires a tremendous amount of experimentation and design and development is probably going to be achieved without some serious accidents. That's true of almost any endeavor you can think of in the world. I'm sure it goes all the way back to the days of humans trying to go out there and see if they could kill an elephant. How many humans at that time died trying to figure out how to kill an elephant just for food? So almost any experimentation for humans to further themselves requires sacrifice on the part of some people. So the Soviet human space programs, as you can see, became the first manned spacecraft to orbit Earth. Yuri Gagarin, the first woman, Valentina Tereshkova, controlled from Earth. That's something I wasn't aware of. It turns out that all of those early spacecraft that were sent up, the people on board had no control over the spacecraft itself. They couldn't take over in the event of any kind of a problem between the ground and the spacecraft. It was simply a matter of if the spacecraft went out of control and couldn't be solved by the ground, they were going to perish. So that's an important element of the Russian space program. They just didn't have enough sophisticated technology to be able to allow pilots on board the spacecraft to make decisions about how to get the spacecraft back down from orbit safely. So that was the Vostok. And these words, I have no idea what they mean. They're Russian. Voskod was the first spacewalk, and it was the first time that multiple people were carried into space. So they were ahead of our spacecraft, where we finally were able to carry 2 people. They had already done that. They had already done the first spacewalk. It wasn't much. They sort of ventured a little bit outside the capsule opening, but they were tethered to the capsule itself. So subsequent to that, we've had spacewalks where the astronaut going outside of the space lab or the space capsule had no strings attached from that person to the spacecraft. What they had on, they had a backpack with little jets to be able to maneuver by using the jets in the backpack to move them farther away or back closer to the spacecraft. The Soyuz, that was originally designed to go to the moon. They never made it. There were so many problems with the Soyuz operation that the Russians finally gave up. It had numerous problems. It had problems of engines. It had problems of delays in design. It had problems of communication. It had problems of liquid hydrogen. And then the Salyut came along. Then they decided that, well, if we're not going to the moon, let's be first in space and establish some sort of a presence in space. And they put up the Salyut, which was the first try at a space station, way ahead of the United States. And as I point out here, it was aloft for 5 years, and finally they abandoned it because they were already building the Mir space station. And the Mir space station was much more sophisticated, bigger. They could do a lot more with it. It could handle a lot more people. So Mir was aloft for 14 years. Salyut, actually, after 5 years, just began its own descent, and it wound up burning up in the atmosphere as it came down. Buran was a Soviet copy of our space shuttle. If you see a picture, I should have put a picture of the Buran in here. I thought it was pretty amazing when I looked at it. It looked to me like it was a U.S. space shuttle on a Russian rocket. That's how closely they copied everything. Now that's what the Chinese did for a long time. That's what the Russians have been doing for the last 50 or 60 years, copying everything they can, industrial, that they can get their hands on in this country, so they don't have to go through the trial and error of designing and developing things themselves. They can just take all the information that was generated by the United States in the engineering and design and just duplicated exactly. They did that with commercial airliners. They did that with the space program. They've done it with their version of the Concorde. Along with the Russians and the United States, the Europeans themselves were trying to do some things that would bring them a little bit of a luster or at least some political consideration around the world. And they did have some limited success, but not an awful lot. And so what happened is France then became the third country in space after China and Japan, and then finally India and Israel wound up going into space. China's in space. I mean, it turns out that any nation that is reasonable in size has already gone to space or provided significant and sophisticated satellites that are already up there. So European space development is not a major memory point for you. What I want you to take from that is the fact that Europe did not just sit still. They did their best to try to come up with some sophisticated space hardware, and they did their best to try to come up with some things that would label them a pretty good and sophisticated continent that people could rely on if they didn't want to deal with the United States or Russia. We already talked a little bit about the jet age and about what it meant for the United States and what it meant for the world. The jet engine brought more people together around the world than any single thing that has ever happened in the history of the world. The jet engine is just a remarkable concept, and it just came from the mind of Frank Whittle. Remember, we talked about that a couple of lectures ago. We covered the fact that Frank Whittle was the man who first came up with the design for a jet engine. He wrote a thesis on the development of advanced aircraft when he was at the Royal Aviation Academy in England. And at the time, he kind of thought, in his paper, he said, I think there's an opportunity for a new development for an engine, and he sort of outlined what he thought would be the new development, and it was received very well by the people who understood what he was talking about. And so when he graduated from the academy, he went into private business himself to develop the jet engine. And we talked about the different kinds of engines beyond the piston engine, beyond the rotary engine. We talked about the jet, the turboprop, and the turbofan. The difference between the turboprop and the turbofan is the fact that the turboprop is a jet engine turning a propeller. A turbofan is a jet engine turning a fan, which happens to be multiple blades at the front end of a jet engine. So every commercial airliner you see today, if you look at the front of the engine, you're really looking at the fan. You're not even seeing the jet engine behind the fan. And the fan contributed several things. Number one, it contributed thrust, because all it was doing was sucking in clean air at the front and blowing it out the back. That clean air also surrounded the jet engine and kept it cooler. That air also was used in a very unique way to keep the noise down from what were terribly noisy jet engines. I remember when the Boeing 707s first began to fly for American and United Airlines out of Chicago. I had an office in a building that was very near O'Hare Airport. And the noise of those aircraft going over is you can't imagine how, it's probably as loud or louder than what you would hear if you were standing on the ground while a military jet took off out of FAT. The noise was horrendous. And of course, then immediately everybody complained. Even people who had been at the airport after the arrival of the jet age, people who had just moved into an airport vicinity, started complaining about the noise. And of course, politically, you can't tell them, hey, you knew there was this noise being made before you moved into your home. So you have no reason to be complaining about it. But that didn't work, unfortunately. That was not one of those things that the leaders of any organization, whether it was the mayor of Chicago or whether it was the governor of Illinois, couldn't tell the people that. But today, we have three. We have Pratt & Whitney, GE, and Rolls-Royce all making engines. And it's up to the person who buys the airplane to decide what engines they want to put in there. Now, some people, for example, at British Airlines, if they decide to choose the Rolls-Royce, they get kind of a discount on the aircraft because they're choosing their country's engine development. But Pratt & Whitney and GE are American engine manufacturers. Pardon? Did somebody say something? Okay. So, today, those are the three companies. You really can't get a jet engine from anybody else if it's that big. But if they're small, there's another manufacturer called Williams Aviation. Williams jet engines have been powering small aircraft. There is something called the Eclipse, which is a tiny little aircraft with 2 people in the front and 4 in the back. And it's used for charter around the United States. And it has a couple of small engines. You can actually just hold them in your hand. And 2 of them are enough to power a jet up as high as 41,000 feet and as high as 550 miles an hour. So there really is another. These companies don't necessarily dominate all jet engine production. They dominate commercial jet engine production, where the amount of thrust is up so high that I think in my lifetime, no one ever thought that thrust would get that high in any kind of a jet engine. So I showed you these pictures. I showed you some black and white pictures that I had taken at O'Hare Airport on the day that Boeing 707 first arrived there and was being shown to the public. And in this particular case, the Boeing 707 has been tried. People have tried to copy it worldwide, and a lot of them have done so. But in fact, Boeing was able to capture such a strong share of the market that, with the exception of Airbus, nobody's been able to ever compete in that particular marketplace. And the reason that Airbus was able to compete was because they got 2 countries involved, England and France, both, putting up huge sums, billions of euros, in order to support the development of the Airbus. When this came along, it was really exciting for all of us because no one had ever seen a tri-engined aircraft before except the Ford Trimotor. And that Ford Trimotor, by the way, has visited Fresno Chandler on several occasions in the past several years, and people could go for a ride in it, I think for about $150 per person. And there was another one built by the Germans, a Fokker something, F-O-K-K-E-R. I don't remember the number, but it also was a tri-motored airliner. It had a piston engine in the nose, and it had 1 on each wing. But when this came along, it was just phenomenal because people loved to fly it. The pilots loved to fly it. This was the one that inaugurated the service between L.A. and San Francisco for $7.50 per person, where you could get in that aircraft. It had brand new, beautifully designed flaps in the wings, so that it could land and take off in short distances. It could withstand something as often as taking off out of L.A., landing in San Francisco, taking off out of San Francisco, landing back in L.A. again, and doing that all day long, which is what the PSA pilots had to do. PSA, by the way, was called Pacific Southwest Airlines, PSA. And they had a grin painted, a wide mouth painted on the underside of the cockpit. That was sort of their logo. But anyway, this was a great engine. I mean, a great aircraft with excellent design. It got rid of a lot of the problems associated with engines on the wings. And if you recall, when you put an engine out on the wing, if you have an engine failure, the good engine tends to drag the aircraft around in the opposite direction. That's true of piston engines. One of the biggest problems you have in getting a multi-engine rating is that you have to demonstrate that if all of a sudden you had an emergency engine failure, that you can control a multi-engine aircraft. And it's not easy because, first of all, if you're flying along and you lose an engine, you know something's happened, but you're not sure which engine has gone. And if you pull the thrust back on the good engine instead of the bad engine, you start descending rather rapidly. So this particular aircraft eliminated the real problems associated with having engines way out on the wings. Okay, that's number one. We're going to go to number two here. Then we talked about this before. Sometime after the development of the Boeing 707, the airlines were saying, hey, we'd like to have a small aircraft to go from, say, Columbus, Ohio to Chicago, or from Chicago to Philadelphia. We don't need a big, huge Boeing 707. We'd like something smaller. So they took the fuselage from the Boeing 707, exact same fuselage, same cockpit, same controls in the cockpit, everything identical, so that if a pilot was flying the Boeing 707, he could immediately migrate over to the 737 with no difficulty whatsoever. All the controls are identical. Everything was in place. The only thing is they shortened the fuselage and then only hung 2 engines on it because they didn't need 4 engines. It was going to be a short-haul aircraft called Fat Albert. And at the time, it was ridiculed. But by now, as you know, the 737 has gone through about 10 different development iterations. I think the latest one is the 737-900, which means it's gone from the 737 to 100, 200, all the way up to 900, and that it's had variations on those. So it's 900-2, 900-X. They've sold thousands of these. Southwest Airlines is probably the best low-cost flag carrier in the country. And that's all they use. They use only 737s because they never have to worry about keeping 2 sets of inventories of spare parts. They never have to worry about crews going from one aircraft to another because every crew stationed in every city has the ability to go out to the airport and get on board one of the Southwest planes and fly it wherever they have to go. Now, that's not true of American and Delta and United. Those airlines have so many different kinds of airplanes that they have to have multiple crews to be able to go on board the different aircraft because you can't go from, say, a 787. You can't just automatically fly a 737, 787, or an Airbus 320 to a Boeing 707. But Southwest Airlines makes money doing it because they thought ahead and said, hey, we not only want to keep the same airplane, but we also want to minimize our inventories. We want to minimize our training requirements. We want to have the people on the ground able to turn that aircraft around in 15 or 20 minutes because they are familiar with the seating. They're familiar with the problems associated with the galleys, everything connected with flying airlines. So this turned out to be such a phenomenal success. I think it's today probably by far the largest selling jetliner in history. We talked about the commercial airliner, this one in particular, the 747. It was a perfect plane at its time in history. Today, it's probably pretty much run-of-the-mill. It's used mostly for cargo today because you don't need to carry around 300 and some passengers. The Boeing 777 carries almost as much in the way of passengers, but it has 2 engines instead of 4, and it has 2 crew members instead of 3. On the Boeing 747, you need a flight engineer that has to sit in the back behind the pilot and co-pilot, and he has to monitor all 4 engine instruments and all the other details. But in the case of the 777, it's so automated, and the engines are so powerful that it's an extremely efficient airliner for the world's airlines. Then they came along with the 757 after the 747. The 757 was a narrow body, but it had a lot of significant advancements in it. One of the surprising things that came out of the 757 was something called severe wake turbulence. Now, wake turbulence is a phenomena that when wind flows over a wing, it tends to slide off towards the end of the wing, and when it gets there, it starts rotating. So an airplane passing through the air at slow speeds primarily produces tornadoes, horizontal tornadoes, off the back of the wing. And these tornadoes, in fact, have upset many an aircraft. Well, it turns out the 757 is even worse than anything. They couldn't figure out why for a long time, but as it turns out, not only were the tornadoes coming off the wingtips, but they were coming off the corners of the flaps. So if a 757 was inbound to an airport and it was going slow in anticipation of landing, it was creating 4 tornadoes. 2 tornadoes on each wing, one from the wingtip and one from the corner edge of the flap. And so anytime you listen to air traffic control, if you're any kind of a major airport and you hear the air traffic controller saying to a pilot, you're clear to land runway 29 right, caution wake turbulence, that means that there's a heavy wide body or there's a 757 ahead of him, or her, landing on the runway and creating wake turbulence all the way down to the point where the wheels touch. As soon as the wheels touch on the ground and lift stops, it also stops the wake turbulence. This was the first wide-body jetliner in Boeing history, of course. Twin aisle in back. Now, the 747 was certainly a lot wider than this. 747 used to have 10 abreast, 9 mostly, but there were situations where they put 10 seats across. But in this particular case, it was a twin-engined, twin-aisle, very efficient, and it was one of the first quiet airliners such that it could land and take off at most airports, and it would not have the same sort of sound pattern that larger aircraft would have. Very, very effective. Here's the Boeing 777, very high-capacity jetliner. That's flying today extremely successfully. In fact, I have to say that the Boeing 777 probably put the Boeing 747 out of business. And the same way it's doing to the Airbus 380. It's putting the Airbus 380 out of business because number one, nobody wants that many passengers in an airplane now anyway, and number two, the Airbus A380 has 4 engines and this has 2. And so in terms of seat miles and the efficiency and the profit to the airlines, this 777 is by far probably the best aircraft flying. And we looked at also the 787, which was the first composite. You know, it's interesting because when I talk to people about airliners, where back in the days we used to build them out of balsa wood, and then we'd build them out of plastic. And here we are today, going all the way around full circle back to plastic aircraft. And yes, I'm using the word plastic a little loosely, but the fact is that plastic and composites are essentially the same thing. And so this thing is made of huge amount of composite material. You probably already know that because you had taken notes on it earlier, and it was one of the test questions. What percentage of composite materials were on the 787? Does anybody remember? Yes, correct. Okay, so then came along Douglas Aircraft Corporation. Douglas Aircraft Corporation was a great aviation company. Unfortunately, they didn't have quite the design and marketing teams that Boeing had. As a result, they were always a little bit behind. They were trying always to catch up. Well, they made a good aircraft. They made a couple of good aircrafts. One of them was the DC-8, and I've flown in commercial. I've flown in every one of these airliners that I'm showing you. I've flown in the DC-9. That was their commuter idea. It turned out great. I think they're still building the DC-9. Now it's called the MD-80 because Douglas got to the point where they were so successful that they wound up going bankrupt, not because they weren't successful. They had the biggest backlog in the history of Douglas aircraft for new aircraft. That is, they had so many orders to fill and they ran out of cash. So as a result, Jim McDonnell of St. Louis decided that he would buy them because he had a lot of cash and they didn't. And Jim McDonnell at the time was making the F-4 Phantom for the Air Force, which was also a very successful program for McDonnell. So along came McDonnell and he bought Douglas. And Douglas, by the way, is still located in Long Beach Airport. So if you're ever down around the Long Beach area, you will probably see a lot of these aircraft still coming off the line. Not the DC-10 because they stopped making that, but probably what they call now the MD-80, which is that twin-engine, shorter version. This one? Because it could not compete with aircraft that Boeing had already had coming out with on a design basis. It was 3 engines instead of 2. It was not necessarily the most efficiently flown aircraft, and so as a result, the airlines were not making nearly as much money with that as they would have otherwise. So it had a lot of problems. They finally just gave up on it. It almost bankrupted Douglas Aircraft from the standpoint of them spending billions of dollars to develop it, and they never broke even on the aircraft. Lockheed the same way, only in the case of Lockheed, doing this in the commercial airline area, it bankrupted them. It put them out of the commercial business forever. Now, you know them today as Lockheed Martin, and they do a tremendous amount of defense business. They're a huge organization. They do a tremendous amount of defense business, and they also man a number of places like Vandenberg Air Force Base. Lockheed Martin has the contract to operate Vandenberg Air Force Base, and I believe they have a contract down in NASA as well. But the TriStar just literally put them out of business. It was too much, too late, never as efficient. It came out at a time when GE, Pratt & Whitney, and who else? Quick. Who was the other engine manufacturer? Quick. Okay. So anyway, and 3 engine manufacturers were coming out with engines that were so big that you didn't need 3 of them, even to carry as many people as that, what we call the TriStar. Okay. Okay, it's a good point to stop right now. We're going to take a 12-minute break, and then we'll continue on for our next class. We'll pick up where we left off here into part 3. We'll pick that up tomorrow at the same time. And keep in mind that 2 days from now you have 2 essays due, 2 draft essays due. And one of these days I'm going to spring a little bit of a quiz on you. It will be an open book quiz in this course. I'm going to continue to give you quizzes in Flight 104. But in this particular course, as I said before, it's going to be mainly a survey course for you. I'm not going to try to make you aviation historians. But at least you need to be able to study enough to be able to get a reasonably decent passing grade at the end of the semester. And by the way, the semester is what, 5 weeks away? Yep, 5 weeks. Time goes like crazy, doesn't it? Okay, go. Break time.